MS Panwar from Department of Statistics, BHU, and as per the schedule of your workshop, it's I think third day, and the topic we have to cover today is the model building in R, and specifically on the logistic regression. And as I come to know that most of the candidates, candidates are from different or various backgrounds. So it's I just try to avoid the slides and let we go with the Jamboard. We just write something, I think, and if there will be any issue and in any conceptual thing, methodology, or in say coding, so there is no need to be wait till the end of the session. You can just interrupt me at the same time, and I will try to clear the point at exactly at the same time. So let us start with the model building in logistic regression. What we are actually discussing in, if you will say, after linear modeling, or yesterday you will complete your linear modeling and multiple linear models. So in that case, you are discussing about a model, and that model was particularly from say y is equal to x beta plus epsilon kind of things. And here you are saying,
The voice is very low.
okay, let me try something else. One second, just give me a second. Is it clear now? Is it more?
Yes, sir. Yes, sir.
Good, 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 good. And
Very low.
maybe you can also check your audio. Maybe it is you just put in the low side. So I think in the most of cases it's good. If one or two say I'm audible clearly or not.
You're audible,
So
sir.
you are audible.
Good, good, good. Then check your volume, sir. And now point is we are particularly talking about the logistic regression. Okay, we will start with I think in a very slow mode, and then we'll go a little faster. We will increase our pace. So logistic model is, before that we just define say y is equal to, we just define a model say x beta plus epsilon kind of thing in yesterday lecture. Maybe in that you are saying say epsilon is following some normal distribution and it is kind of additive model, and with some parameter g or sigma square, you are saying say y is following normal distribution and so many things. And we are saying say this distribution is linear just because of its parameter, okay, in parametric form. So parameters are in linear, that's why we are saying the model is linear. So we are just putting a few things here. In some cases, the program arises or the data arises in such a way, say this particular variable, what we are saying y, is in general not in as such numeric form, or we just say it is classified. In some time we just say it is classified in such a way, say it can take values. In particular, say we are saying either 1 or 0. Sometimes we say it is a dichotomous, or we will say a categorical data. In sometimes say it may be like yes or no at the same time, or it may be say sometimes say either pass and failure kind of thing. So when you just categorize your data or your response variable in the form of category, so in that case you have to go with different kind of modeling. In that time, this particular model will not be as such suitable. So that is the origin of logistic model. We will say why we are using this and what kind of function is actually logistic model cover. So overall, the first thing is, if whatever is the value of x, if your variable say y is in the form of categorical or dichotomous form, particularly 1 and 0, yes or no, or pass or failure, or you just at some time try to find out the status. Say you book the ticket and say in waiting or confirm. Okay, so when there are two such kind of conditions, then we just go with the classified data. So there are a number of examples. If we will say related to this particular, if your data is, we will say in your mail data, so you can say a mail can be spam or not spam. You can take a mail in that way. Okay, you get number of mail in your inbox or your Gmail or whatever the ID you have, and then you just say you categorize that particular mails in two forms, either a spam or a non-spam condition, or you say a disease status, you say disease diagnosed or not. Say status is disease, we will say particular disease diagnosed, detect किया है, otherwise you may say at the same time not diagnosed, disease not diagnosed kind of condition. So there may be two conditions on the basis of some test, and you just find out that, or the medical person say the disease is yes or no, that kind of conditions. Or sometimes we just go say check the liver, it is a fatty liver or not a fatty liver. You just on the behalf of some volume and some dimension, you just justify that. So that's the overall response, whatever the value of say volume or area or whatever the value of that. But at last your response variable is this fatty or not? Okay, so there are two conditions. If you are there are moderate and severe, and then so many things. But on the basic level, we are saying say we are categorizing only two parts. Either it is yes or it is no. Or sometimes say fraud or not. Fraud detection cases, you just say there is a fraud or not. In some say cases, you are saying it is a fraud or not a fraud, like condition. So these are the basic example we can take in our real life, which somehow match with this problem. Okay, in the medical field is especially, or in financial areas, it is widely used logistic regression. In that cases, we just make the things in categorical form. So that is a particular way to, or the simplest form is a win or loss. We are just going with win or loss. Just gambling, and in many cases, even the cricket matches, you can say, what is the condition, say, win or loss of India team. And you can associate this win or loss is, say, if sometimes we say if Sachin Tendulkar will give a century. So what is the condition if in probability of India winning, if he just goes with 100, or he just go loss if it just century in that particular match. So in that case, this is your like X. So we can say what is I scored by a particular pair, say or say you can, if you are just interested in this, you can say. So if any player, if you are associate the X as any player score in that particular match, so it's scored by Virat Kohli, that might be say something around 20, 50, 100 to 120, like that. And then how you will associate this X, this particular score, with your response variable, which is India win or loss. Okay. So somehow these things attached. So in that cases, the issue is if you will try to find out variable, we will just give this our coding for this also. What we are saying, we are considering an X here, and at the same time we are considering Y here. Okay, so you'll find if we just give this categorical by a numeric value, just assign y 1 and 0. So in that case, there is a value 1, 0 is here, say, and 1 is in this case is here. So on y-axis, again, we have just two values, either 1 and 0. But on x-axis, you have so many values as per the value of x that is distributed over that. So in case of this, say we just consider the score. So if we are just saying, say, if a particular score from, say, 0 to, say, 10 to 20, and then such, say, here we are going 150, like in the observations. So few of observations will like in that way. Okay. So in that cases, what will happen if his score, it is quite good chances if he score low score of Virat Kohli in particular match. In that case, you will say the Y, the winning chances is quite low. Maybe it can win, but at the same time, even he score 100, then obviously possibility that India lose the match. At the same time, there is a possibility he score low, but India win the match. So that kind of data we just find in that case. So overall point is, so we can replace this like we will say this X is kind of platelets of some in case of some particular patient, we are defining like that. So we are diagnosing the things or infection kind of things. The infection is available or diagnosed or not, that will be somehow dependent on the, say, we just, I'm not an expert of this thing, but even though I can just confirm that on the behalf of platelets, we are just trying to find out the infection is there or not. So if we are saying, say, if, platelets in the range of, say 20 to, say, around 70 or 80 lakhs, then 80,000, then the thing is different. And if it is more than 80, then the chances is very low. So in that case, the similar things are here. So point is, if your observation says in this time, if you are just talking on the terms of thousands, So if X is your platelet, so in that case, if it is around 10 to 80, then chances then there is infection. So we are saying this is assigning this say by 0. But in case if it is more than 80, then there are rare chances, then it goes with 1. So overall, whatever be the value of your X, then correspondingly, the value of Y will be either 1 or 0. So this is not kind of a continuous variable. So in I think the base is clear why we are going with this logistic regression, or why we are avoiding the simple linear regression modeling or multiple linear regression modeling in this case, in that kind of data. Okay. So I think if there are any query or any issue, you may ask at any time. I'm again saying, or I can ask, say, give any other example you think that will say fit or suitable for this kind of data, or match with this data. Anyone else? If you think that this particular example can be matched with the logistic regression setup. अगर आपको लगता है कि कोई इससे मैच करता है तो आप देखिए कि ये पर्टिकुलर केस है. You can just give your example of your field. If you are say just working in the field of biostatistics, in the agriculture, economy, psychology, in your field, of course, there is some data where you will getting the values in terms of 1 or 0. Okay, so a simple example we are considering, say if there are some person, there is a number of students in your class, and you are just interested to find out you're just trying to categorize on the basis of data, on the basis of their height. You are interested to find out the gender of the person. Either those are girls or boys. So your whole class is divided into two groups, girls and boys. So either one is you can consider girls as a 1 and boys as a 0, and then correspondent then as per their height, as per their sometimes last few months back, I'm just reading some AI article in that they were just trying to detect such things on the behalf of the length of the hair. Okay, so if you just identify the length of the hair, then on the behalf of that you can somehow easily identify then the particular person is a girl or boy. So these things use in the scene of a crime scene, and so many things when say these particular outputs, say Y, can be detected on the behalf of X. So there are so many examples or so many real situations when lastly we just categorize the things either yes or no, either win or loss or pass or failure or 1 and 0 kind of things. So you have to identify the your X and the variable, independent variables, and it may be more than one. Right now we are just considering only one X variable, and then on the behalf of we are just going with the Y. Now the point is, can we just draw such data? Either we just consider a real lifetime data, but I think that will just belong to a particular group. So we are just trying to make data on our behalf. Okay, so let's consider this studio. We are just going with this. So we are going to code parallelly. So if you are also better, if you just go with me, if you just also type in your system, then you will actually understand the things in much better way. Okay, it's so still I'm saying, if you have any other example which you think that it meets with the example of logistic regression, you can just share with us. We can going with cobalt is better, and let's add some. I think it is okay. Good. Now you can recognize this easily. Okay, no one. Okay, the point is I'm just going to give you some code on. So I will design a data which will somehow match this data of say logistic regression, and you can also type the same thing, same code, and if you have any doubt or confusion in writing that code, I will try to make it clear, but if you have, then you can ask at the time. Okay, so actually what we are doing a logistic regression, this. Okay, and we are just trying to find a data. A data belong to this. Generally, we say dichotomous. Dichotomous. I think right spelling. The word is quite confusing. But the point is, in which we are in, the where thing is dichotomous in the sense that it is in the form of binary. Okay. So what we are saying, say we have some observations. The similar plot I just draw with the help of say x and y axis. Actually, that's why I'm trying to put here. So your data will look like that. Okay. The point is, say we are some generating some values. Say we can define in some way. Say x1 is you are generating few values from m norm. Say we are considering set of say 20 observations, and these observations belong to normal distribution. Say some parameter we are saying 50 and say some variance 20. Okay, so I think there is no such issue with that. So no doubt there is some observations, those belong to, we will justify this what it is this, or you just go with, you may round better this uh, with first or second decimal point. This will be easy for us to the next. So these are some observations. We give some particular name to this. Then we are just taking the second variable. Say x2 is again a round, and in this case we are considering, so this is say 120. Or you can just add some more variance in that. In that case, we again taking another variable, so this is x2, and here is the data. So we have two kind of observations. Overall, we are just trying to mix this in such a way, then those are look like, we are just actually what we are, it is sometimes called in statistics, but particularly we are artificially generating some observations, some data, and try to match the it is to the real situation, or sometimes they cook the data. Okay, cooking the data. So here we are just artificially we are utilizing this. So overall we have x observations. Yes, we have x. Yes, Anshuman.
Can you explain the command round? What it do?
Okay, good. The point is when we are just generating say normal, I just generate when normal observations. Okay, R norm I think you are used to with that. This is the random number generated from the normal distribution. 20 random numbers. First stand for 20 is the number of observations. 50 stands for the mean of that normal density, and 20 is the standard deviation. Okay, so this is the normal numbers we are generating, say 20 numbers, but in this case the point after decimal is say 5 or 6. Okay, so we are not interested to add that kind of precision. So in that case we just round these observation up to first decimal point. Okay, so now all those observations just somehow we just say rounded up to the first decimal point. You can increase up to say 2 3 4 5. So it depends up to the efficiency or precision you are expecting from the observations, but in this case say we are just interested only the one decimal point. So we just cut all other values, actually rounding all other values, cut is a different thing. So we just rounded this up to the first decimal points. Okay,
Yes, sir. Thank you.
okay, good. So that's what I'm expecting from all of you. If you have any point, any doubt to any command or any syntax, you can just raise your hand. I will just answer at the same time. So point is, what I'm trying to do, say we just, there are some x1, x2, and lastly x. Once I just make this data, then I will try to make this look like a real data set. So we are just repeating. REP is a repeating kind of thing. So we are repeating from 0 or say 1 for 20 times. At the same time, we are repeating. So C stands for design the vector. So overall we have 40. Sorry, overall we have 40 observations. So what we are doing, say this is our data. Say this is Y. Good. The point is, if you just want to see then in another form, so see you can just see bind all that. REP for repeat. So we repeat this 0 term 20 times. What it has done? REP just repeat 0, which we are just interested to design a vector of your choice. So what we are interested to, we just repeat 0 as a 20 times. So if we just consider 0 as a 20 times and 1 as a 20 times, so overall Y is a vector of 0 and 1. First 20 observation is 0 and last 20 observation is 1. So overall thing is we have we just C bind x1, x2 and Y. So C bind is simply bind with columns. So in that case we have that kind of data. Okay. So what this data actually done, we have some observations from x1, some observations from x2, and at the same time y. So that kind of observations we have, or you can just consider that as the row wise. But the point is, what we are trying to do is, so thing is, if you just, yeah, okay, this will be repeated. Better that if you just consider this. So yes, that will be the better representation. Then I will define why we have done this. Good, that's the point. Say what we are saying, say this is say ds. We just give it the name, say ds, and lastly we just say ds is this. So let me explain this, why I'm doing this, and then after we will just continue with the other steps. Okay. Good. ds is here. Few observation is negative. We will try to avoid this. We can set a seed for that. In that case, seed. Let's say 1, 2, 3, 4 something. Good. Okay. Good. So let me check what we have done or what we are trying to do. The point is, if you are saying, say x1 is, say few patients, in that case, observation is around say 100. So we are saying, say these are the platelets count, okay, and it's of course in thousands. So we are generating x1 observation. So x1 observation belongs to first 20 patients, those who doesn't have those that have that particular disease, that the platelet count is quite low. So in that case, their generated platelets are belongs to x1 vector. Okay, that belongs to x1 vector. And then x2 is, we are saying their platelets count is around 120. So we are saying those are infection free or disease free. In that case, their platelets is relatively high. So in that case, their data belongs to x2 vector, which is belongs to the patients who does not diagnose with that particular infection or disease. So x2 belongs to those are disease free, infection free, and x1 belongs to those are with infections. So what we have done, we just generate y. Y is a vector which we are saying, say particular cases 0, 0, and then 1, 1. So means to the first x1, the size is 20. So to the first x1, we just assign a 0 number, and the last 20 x2, we just assign a number 1. Okay. So in that case, when you are just interested to find out the disease status, we just say ds. So in that case, you will find what we have done. We just make a data samples observations in such a way that the first 20 observations up to this 20, this particular x is defining the platelets count. Okay, 82, 73, 40, 60 C, and these are the same platelet counts in 1000, and with 0. Okay, these are diagnosed with a particular infection, and remaining after 20 to 40, these numbers belong to the platelets count to the persons, those are disease free. So in that case, their status is in 1. Clear? So overall, you will get the data in that kind of form. In case when you are just doing a logistic regression, yes, set.c Sunday. Okay. The point is, once we are just saying, it's a, let me give you an example. Say what we are doing, if, okay, Sandeep is asking what is the meaning of set.c. So there is a command R known. We are just saying we are just generating one number from say mean 0 and variance or standard deviation 1. Okay. So if we generate a number from this, the number is 0.026. Okay, like that. But if we again run this program, this number is minus 2. Because it is randomly generated. Again, you will generate this number. So it may be minus. The point is that all the time when you will generate a number, a random number from normal density, normal function utilized in our software, what it will done, it will generate a random number from the normal distribution from with the mean 0 and standard deviation 1 in the range of a normal distribution is minus infinite to infinite. So there are infinite number possibilities. So it is very rare chance that this particular number match with another number. So all the time it will generate a new number as per the density of normal distribution. But if what we have done, if we just set dot seed, point is we just set the seed 12. So what it has done, this set dot seed, if you generate a random number from this, sorry, in that case, all the time the number will say, if we just set the seed, that all the time the number will say. If you set the C12, then random number is all the time minus 1.48. Okay, I think you got my point. If you set the seed, the point is at that time the randomness of that data will just fix to a particular number. All the time the rnorm command is providing a particular number. Okay, minus 1.48. But in previous cases, it's all the time it is repeating these things. It will just generate a new number. So what it has done, for that we have to go to the actually basic theory of what we'll say of random number generation. Once you generate random numbers, don't use a pseudo random number method. That is a little difficult to say, but the point is your random number is actually a sequence which is obtained from a very high length, or from where we are just sequentially generating number. Those are looking like a random number. But here I just simply say, good. Okay, Shilpa. That's what I'm trying to justify. What is the significance of this? Significance of this is that if you just set a seed, then all the time your random number will generate the same numbers. If you set the seed,
Sir, I was asking about this argument that we are passing. Once you written that 12 here, earlier you used a different number. इस 12 का कुछ significance है या फिर हम कोई भी number use कर सकते हैं?
एक्चुअली थोड़ा सा ये आउट ऑफ द वो है, लेकिन मैं फिर बता देता हूँ. एक्चुअली क्या कर रहे हैं, द थिंग इज कि in case of random number generations, we are generating using the uniform distribution as per the definition of that CDF of every distribution is following uniform distribution. So the point is you are generating random numbers with a sequence with the infinite size width kind of thing. So in that case, when you just set a seed, then it will take a seed 12, and then accordingly the sequence will start in somehow I will say 12 number. Okay, then all the time the first value will be start from the 12 number as per the sequence of uniform distribution, then accordingly random number will be generated. So point is you can consider any sequential point, any value, whatever you just find out, whatever you just think. So it is just the initial, or sometimes we just say it is a kick start value. Okay, seed value. The point is whatever value you just consider that value, and accordingly you will get the same number all the time. If your seed is fixed, then corresponding to, okay, good. If your seed is fixed, then corresponding to that seed value, there will be a fixed random numbers. So in case of random number, it is quite difficult to say it is fixed, but all random numbers are generated as per some predefined seed. So by default, it will consider the different seed value all the time. But if we just fix the seed value, then accordingly the normal numbers will be generated fixed. So what happened actually when we are generating random numbers? If you just you didn't, I think, capture the point why I just fixed the seed. I just fixed the seed. Few of normal numbers were negative. Okay, because the range of normal distribution is minus infinite to infinite. So there is, if you are considering mean 50 and the variance is in division 20 or 120 or 30, yeah, there is quite rare chance there is some observations from the negative side. But even though there is some chances, because the range of normal is minus infinite to infinite, so in that case, to fix this issue, what we have done, I just choose a particular seed. For that particular seed, say number this, or you can take any value of that. For that particular seed, there is no observation in first 20 belongs to negative. So in that case, if you are just saying, say this x1 is representing a count of platelets, so platelet count cannot be negative. It can in the most worst condition, it can be 0. Okay, so but it cannot be negative. So avoid this phenomena in real life situations. What we are consider, we just consider a particular seed. For that seed, normal number are generated from, particularly from positive sides. Okay. but it will not going to affect as such the character of the normal distribution. Okay, because lastly those are generating from the normal distribution, not from any other density. So I think now it is clear. The point is what we have done. Let's come to the point again. What we have done here, we just set a seed, set dot seed. We just find out few 20 patients. Those belongs to those are infected, so their platelets count is respectively low, around just distributed around the 50. So first patient is 54, second patient C bind. Okay. Karthika. Okay, I will just define the C bind. The point is, next is we are just defining the X2. X2 is somehow the platelet counts is distribution around 120. We are saying those are disease free or infection free. So overall data is X. X is all 40 patients with their platelet counts. Then we are assigning Y. Y is say particularly 0, 0, and 1. What we are saying, say first 20 patients are disease infected and the last 20 patients are non-infectives. In that case, overall Y is their particular status. Now, this is DS. We are saying the disease status. So we just assign the disease status. What it has done, it has particularly assigned the Y value with corresponding to the platelets count. Now, the point is what is C bind is doing. C bind is particularly keeping these. Here we define two vectors. The first vector is this overall. Okay, this is one vector and then separated by a comma. Y is another vector. So there are two vectors. So what the C bind command does, it binds these two vectors as per column. So now your data is DS data is looking like two columns. Okay. So if you can give some, say if I just say COU count is equal to this. So I think this will work like this. So you will get two columns. The first column is count. We just define the name of first vector and the second vector is Y. Okay. So overall, this is the disease status. So C bind is working as a column, and at the same time, you can say if we just interested to bind this as a R bind, of course, C bind is column wise, then R bind is of course row bind. So now your data will be not in good in looking form, but the point is now you have two rows. First row is count and second row is Y, and your data is now distributed as per row. The column is now 1 to 40. Earlier row was 40 and column was 2, but now column is 40 and row is 2. So these things we generally utilize to actually visualize the data in between the program. So I just keeping this as a C bind. There is no other meaning. We just define the data frame or sometime some other vectors in next command we will use. Okay, good, Karthi. Now the point is we just define an observation. So overall our data is looking like say DS. And if somebody says that it is well defined, then first 20 observations belongs to 0, say infected, and last 20 observations belongs to. So this is quite easy to understand, but it is just what we are saying. If we just want, we can just mix all these things. How we can mix the thing? The point is, let we define a sample. Say we are saying, say Z is equal to sample of say from 1 to 40, total observation are 40, of size say 40. I will say why I'm doing this, and replace is I think by default is false. Good. So replace is false. So what it has done, it will give a sample of size 40 from the observation 1 to 40, and the replace is false. Replace is false means once an observation is picked in first draw, then it will not be put again in the samples. So now out of 39 you have to choose the one, then out of 38 you have to choose the one. So, and these are with equal probabilities. In that case, this is our sample. So there is nothing else. We just randomly take all those observations from 1 to 40. We just assign a random number to them. Say 39 is the first one, the 35 is the second one, 17 is the first one. So all the time, as much time you will just run this command, these values will be different. Okay, now in another sample out of 40, 420 is this. So what we can do, say we are just saying we have a report of 40 patients. Okay, and in this report, what we are doing, we are considering the sample, say Y, what we can say disease status, disease space as per Z. So now you can understand what I have done. Say DS is a vector, of course, no issue at all. Now the point is what we can do, we just go with the row and the first column. Just create a data frame. Okay, lastly say our frame. So this is what we have done. DSZ1 is the first column, at the same time DSZ2 is our second column. At the same time we can give some name to a particular name. Say this is, here we are saying, say this is count is equal to this, or say we are saying, so this is platelets. Okay, so PLT, we other define this PLT, and this is your the infection is equal to this. They're saying already defined, so we are just taking infection. So that, yes, it is running, and overall your report is that kind of data. Good. Now things are looking better. So let me define what I have done, then I will just go forward. What I have done in previous case, when we are just defining this DS, in the DS, the first 20 observations was infected and the last 20 observation were infected. So in general, we do not find the observations in clinical test. Some that platelet counts reports are patients are coming in the say in some lab, and they are taking they are giving their samples, and accordingly we are just counting their platelets. So it is not possible that the first 20 observations were have say the infection in the last 20 doesn't have the infection. So in general the things will be, say first patient is non-infected, second patient is infected, third patient is infected, then fourth patient is non-infected. That kind of observation we will get. Okay, so what we have done, we just take a sample, we just take a random sample without replacement, and we just get 14 numbers with the replacement false. In that case, we get some Z values, and we just put those Z values in this DS values. So what it will consider the first value of the fifth patient in that sample. So fifth patient is actually come very first in the to test their sample. Say platelets count. Then 36 patient come the second time, the 35th patient come at the third position, 25th patient come at the fourth position. So that is the situation. So in that case, the report that will be generated lastly, this will be look like this. So this is a data frame. In this data frame, what we are saying, say first patient with platelets this is infected. Say infected is defined by 0. And 53 counts is infected, then 1 is 108 is non-infected, 119 is non-infected, 71 is non-infected, 56 is infected. So this is our actual data. We are saying this is the data we are observing in our study. Now the point is, so we are just make a dummy data, artificial data or a cooked data with which we are just going forward to fit a logistic regression model. Okay, so point is, how it will come in our mind that we are going with logistic. Why we are not going with yes, Anshuman?
Sir, Z is a random sample.
Okay.
Every time it generates different random sample.
Mm-hmm.
When we apply report, then it every time it gives same random sample, same sequence. Why it is happen? It should be different.
It will not give the same sequence all the time. Say Z is in this time, in the first 27th patient on the first, but in the second time, 5th patient on the first. In the third time, the first patient on the first position, and according to the 29th patient on the first position.
No, sir, when we apply command report, sir, when we check our report variable, then it gives same report, sir.
No. I think you just run. Say if you will say this time the report will. If it generate this, in that case, in the report, first position will be first person will be the first position. Now it is 71.1. Okay, and if you just generate this again, in that case, the patient
Okay, sir. I understood. I understood. I mean,
32.6. My point is, once you just get the data in that data, the things are not as in a sequence way. The first we will get the non-diseased person, and last we will get the diseased person. The point is, all such reports will be mixed up. One patient may be disease infected, one patient may be non-infected, then someone is infected, then someone is not. So that kind of data we just generally occurred in our experiment. So I just design our report in such a way that that data looks like that. Okay, that was the overall purpose of doing this. I think, is it clear to everyone now? It's still, if someone have an issue. Yes, good. Yes, anyone else? Shiva?
It's clear.
Okay, good. So now the thing is, we have some data. We can give this data any other name. Like you can give at the same time we are just considering as a score. So you can say just try remove all the decimal points. So these 32, 45, 64, 69 can be considered as a run scored by say a particular player in the particular match, and accordingly you will say that the match is lost or match is win. Okay, if it is giving the hundreds plus run in that particular inning, that chances of winning is high, is it likely 1, and if it is low, then in case it is 0. So things can be matched with any real life situation. The overall point is we have just generated a data that is categorized as per their response variable, either infected or non-infected. The point is how it will look like. Okay, so this is the data. At the very first look, we have to decide we are going with logistic in place of say linear regression. So it's plot. If we just plot this data, so in that case, this plot must be look like the thing that we are just going with say logistic. So of course we are going to plot what our report. Okay, in this report, first two variable x and y are well defined. And we can define, say, some special argument to look like this better. See, we will make this better at the same time. So if we just plot this, then this data will look like this. Let me make this good to see. We just define a background. Say we are considering yellow is our background, then this plot will look like this. At the same time, you can choose some pixel character. Those are better in the previous case. Yes, it's good. At the same time, okay, we are interested to define, say, X lab. What is the labeling on the X axis? Say you are saying say platelets, and on the Y lab you are saying say this is what we are saying. Is it, let me write, then I will say. And on the main we are saying, say comma will be here. In main we are saying, say we are interested to status of the patient. So overall this is my data, and we are just exploring, or we are just putting this data in that kind of format. Is it clear to everyone? We have some values in terms of report, and the report considering two columns, and the first column is count of platelet counts, and in the second column it is status. Okay, so this is not actually infection status count. Plate count in the platelets counts on this count, whatever the counts, and infection status on the this. So these are our labels. So on the x-axis we are considering platelets count, and the y-axis we are considering the infection. Okay, is there an issue with this? So now if you will see, the point is, then this data is nowhere looking like the data with you have already do your linear regression or multiple linear regressions. Okay, it is quite different from that. So this is the data we are discussing in the very early in this session. These things are either in this 0 cases or in this 1 cases. So what we are saying, These are the patients we are considering here with y is equal to 0. Those are infected. Okay, so their platelets count is as such low. It is distributed around 50. So as per their platelets count is low, so in that cases, the corresponding they are getting infected. Say infection is as a response variable. At the same time, their platelets count is high. So corresponding to this, the value is 1. So in fact, those are infection free. I think there is no issue. But the only one thing I would like to ask you, is this right to, it is correct to write here on the y-axis, this is the infection. It is a 0, 0.2, 0.4, 0.6 and 1. Okay, so the overall value of infection is either 0 if it is infected, or either those are infection free. So there are only two possibilities. So y-axis is something different. And even though if we are just interested to fit a linear model on this, we can try that model. So say we are saying a model, say one is our model, and I think you just go with the LM thing, and we are just considering report dollar say infection, and you are trying to fit this report. We will try to minimize the inbuilt command. We will use as such as possible platelets. So this is our model. Of course, your data in this case is report. Okay. Someone will run, you will get some coefficients accordingly. If you're just trying to find out the coefficient, you just go with the coefficients. So here are the values of intercept and the values of course, if it is your model is beta naught plus beta 1 x prime. So in that case, this is your model. You can go with the predict function, or we can simply plot lines on this. So lines is what you are just trying to put some values over this. So let's define a variable. Say x is a variable which is a sequence. If I'm just trying to avoid all the defaults command, I'm just putting all basics command with which we are going. So there are so many commands. I think in yesterday lecture, the person had defined about the linear modeling. I'm just using the simple commands with which we are going. Say we are just taking, say it is going 150 to around 200. And with the interval, this x-axis sequence is like that. Then we are just plotting those points on this with this model. So your model is, or equation is, say your predicted P1 values. P1 of this model is nothing else, simply the coefficients of this. These coefficients will be utilized. Say the first coefficient, and the second one is the second coefficient, and into the values of say this x. So what we have considered, just 1 second. What we have considered, I just take some values of x. X is actually plate counts. Okay, so we just distribute the plate counts from 10 to 200, and then accordingly I'm just trying to fit this simple linear model, and the model with coefficient value, the first and the second value as x. Okay, I think this can be, so we can use any low level graphics function which can be edit this earlier high level graphics function, which is just pop up with the help of the plot function. So lines is the better option. We are just going with the lines. You can go with the predict command also. I'm just using the line. Simplest thing here. So in respect to x, you are just interested to plot P1, and I think it will give some what is P1 is missing. Okay. So here is the curve. Okay. If you have any doubt in any line, you can ask me as usual, as you are interrupting me. The point is, if you are just plotting or fitting a linear model, we just calculated the coefficient with the help of say LM function on this data, this will be look like this. And I think in very first view, it is easy to understand that this linear model is nowhere to justifiable for that kind of data. If anyone have any doubt with this? or in any command, why we are doing this? No. So,
Yes, sir.
Anshuman, is that point?
Sir, it is clear.
Clear, good, good. So overall, the point is what we have done in the around last 1 hour or 45 minutes. We just define what is the condition of logistic regression or when we will use the logistic regression. The point is what is the situation of real data. So accordingly, we generate a real data. We are saying, say, it is stored in the report, which is here displayed by the, say, red dot circles. Okay, red circles. Then what we have done, we just identify why we go with some other. Let me first check the linear model is good or not, and then we just fit the linear model and that data. We just find out the coefficients, and with that coefficient we just find the predicted values directly in the P1 function, and then plot xx versus P1, which is simply defined by this line. Okay, this back line you can just give a LW in generally. It defines is equal to 2, a little bolder, period 1. Okay, so it will be look bolder. Even you can consider any color at the same time. So it is 3. So this is the line. So point is, overall the point is it is nowhere looking good to fit a linear model in this kind of case. If you will see, the point is, in what will come in our mind in the next step is, if of course first we see the observations and then we try to explore what is good for that. In first cases we are saying we are considering or we are trying to find out a curve which or a relation or a function for this data in which have a very small value. The value of y is near to 0 in the initial phase, in the first half phase, like up to 100 or below or 80, and then after it moves upwards and up to the say ceiling, and then they will take all other values up to say 150 or 200. Okay, not like any other polynomial function. So this function is looking like different. So in general, that kind of function, if you will say, come under look like S kind of functions. Okay, S shape function we just generally say. And as we say, we are interested to find out or search a S shape function. In the very first thing which come in our mind is that sigmoid function is the best choice, maybe the best choice for this. Okay, so what is the sigmoid function? That the first condition is this. So let give a quick look to this. What is sigmoid function? So this can be defined, say, with the help of this. If we'll say what is sigmoid function. So point is, why we are trying to identify the point is as says our values is assigned either equal to 0 and 1, and what we are just fine with the values of this, few values are here, and then some few values may be like this. So point is a function and which is like this might be a good fit. Okay, so this is in general called as S-shape function. Okay, and the better choice for that kind is a sigmoid function. Sorry, sigmoid. So this is simply sigmoid function. So what is this function is? We can generally define this by sigma x, and sigma x is simply 1 upon 1 plus e raised to the power minus x. This is the simplest for a sigmoid function, this kind of function. We will see how it will work. And at the same time, this sigmoid function, if you will say, it is of course E is your Euler constant, Euler's constant. Of course, everybody knows. And the Euler constant with some value 2.7 or what, not exactly I know. The point is, if it is a sigmoid function, in that case it has some particular property. We will check all those properties at the same time. So those properties will be utilized in our logistic regression model, and those properties are, let me check, I just trying to find out yesterday. So in case x, the domain we will say is minus infinite to infinite. I'm just giving a quick look. Sigma belongs to your 0 to 1, which is important. That's why we are utilizing this. This is your sigma x function. Okay, this is your x. Your sigma x lies between 0 to 1. Okay, And in this particular case, sigma 0 will be, of course, this will be 1, the 1 by 1 by 2, so it is 0.5. So we can say sigma 0 is equal to particularly 0.5 in case when it is x. And one more important thing we will see, that the first derivative of this is nothing else, it is a form of exponential function. So this will be sigma x and 1 minus sigma x. So these are the functions, and of course it is monotonically increasing in continuous everywhere. It can be defined in the negative as well. It is not necessary that it is 0. It can be defined up to, say, we are saying minus infinite to infinite. So these are some basic conditions, basic properties of a sigmoid function. So we can actually use this I will say, we use all these functions quite blindly. So at least we have some idea why we are using this and how this function will work in all the conditions. So I'm not going to take this more mathematical. So better than that, in place of mathematical, we can just go with in geometric way or geometric view of this function. That will be better. You will understand much better way. In case of that, if we're just going with sigmoid function, actually it is a family. There are a number of functions. Those are in the form of a sigmoid model. I don't know it is sigmoid or sigmoid actually. The point is, what is a sigmoid function? We can define, say, if you have we considered xx and so many x already. So say S1 is here, is a sequence we are generating from, say, minus 10 to 10. Okay. So in what we are interested, say we are interested to find out, to look like, to check the sigmoid function actually. So what we have defined the sigmoid function, say S dot f is our sigmoid function. So that function is nothing else 1 upon 1 plus exponential of and minus of what? S1. Okay. So just define a sequence. Say S1 is that sequence from minus 10 to 10 we are considering. Then this function is nothing else. The sigma function, sigma x is nothing else 1 upon 1 plus exponential of minus of that x or this. So in which we are interested, we are, say, this, let's check at the same time. Yes, S1 is the sample generated. Then S dot f is defined at the same time. The point is what we are considering here. Yes. Is it not? I think I have shared. This problem is everyone?
Yes, sir.
Yes, sir.
Can you see now?
Yes, sir. Now it is
Yes,
visible.
sir, we can see.
Good. Okay. The point is what we are trying to do. We are just defining a sigmoid function. Actually, we are interested to see how it will look like. How a sigmoid function will be look like. We just find out this all the time. I will just even suggest you, when you are doing that kind of calculations, if you are not as much aware about the mathematical properties of that function or that model, so better try to make some geometry of that, some sketch of that, plot of that, and on the behalf of that you will get that idea. Okay. So overall point is we have some, say, S1, some values, and accordingly we are interested to find out a plot of this. So if we are simply plot say this S1 versus, say, this S dot f. Okay. So our plot will be look like this. This is our sigmoid function. So there is nothing special in that. And if you just want this to look like more smoother, so you just increase the number of values in this. So we just put the sequencer at the difference of 0.1. So now this will be a function which can be seen in this form. Okay, so this is a sigmoid function. It is quite clear to understand. At the same time, if you will try few things, say we add some AB lines here. What AB line is doing? AB line is, say, if we are interested to put a vertical line at V is equal to 0, at the same time we are interested to put a horizontal line at H is equal to 0.5. So these are the much better structure. Okay, can you see that? Let me add some color function to make this. Say, 2 is here. Okay. So this is your basic sigmoid function, which we have utilized, which we are going to utilize. Now you can see in the early phase of this function, or in the first half of this function, most of the values are near to zero. Why we are using this? Why we are explaining this? Because the previously we have a plot, this particular plot, where observations were either in the floor in one way. In the first phase, in the first half, observations are on the floor, on the up to the values say near to zero, or actually zero, and in the last half it is up to 1 on the ceiling. So the point is, you need a plot which is just look like this. A linear plot is not feasible for this. So in that case, we can consider a function look like this. So this particular function is somehow looking good to plot or fit this situation. Okay, so in very first look it can be justifiable. Okay, it is looking like the same, but the point is, yes, minimize if this particular in yours is this are in our if this problem is particularly for your margin, you just better stretch this particular either left right side. It is, you just put this is very smaller side. Okay, then it will not plot the particular function on your plot window. So better to make margins in better way. Okay, so it can be, if you just give a smaller way, then it will not be particularly seen correctly. Okay, now the point is, the overall your plot is here, your AB lines are here, and these are particularly going from here. But thing is, this particular function is what I'm going to make. It is more, if in some sense, in more, if you will, I will say, generalized form. So this is the quite basic form. Let me add some particular coefficient. Say AA is a value. You can consider any value. Say I just take, and BB is the another value. A and B, sorry, not comma, semicolon will be here. BB is another value. You can consider, say it is 3, and then you define a new, say, S naught, if it's already defined, so the Z naught. I just take a value of this sequence, Z naught, you can consider F is equal to this, and this is a function of AA plus BB into S1. Okay, the point is what we have done, and then replace this by Z dot F. What you have done, we just replace this function S1, the simplest form of sigmoid function, with the help, we just generalize this for different value of AA and BB, the shape and the position of this sigmoid function will be changed. Okay, what we are trying to make this as advanced or as general that can be utilized for over data purpose. Okay, that's what we are trying to do. So means, what will be the effect if we just define A and B, and then accordingly function Z, it will calculate this for the given value S1, and then we will put all those values minus of this. Okay, so AA and BB is here, accordingly Z dot F, and then S dot F. Then if we just plot this, then there are some minor changes in this function. If you will see properly, then there are some changes which are different from the previous one. What happened earlier, if you will see, this particular plot was passing through the intersection of these two lines, of these two horizontal and vertical lines, but right now it just shifted towards the left side from this. Okay, so as per the value change, as per the values with the A and B, you can generalize this. So A and B is, if of course, if A is equal to 0 and B is equal to 1, then accordingly it will pass through this value. Okay, but for different values of this, and particularly I think if we consider a vertical line is 0, just define a vertical line at 0 as well as, if I'm not wrong, so this AA by BB. Yes, this particular line will pass through the midpoint of this, minus AA by BB. For different values of this A and B, it will be shifted from one side to another side. If I just consider this minus 3, I think, if BB will be minus 3, in that case, this will be, okay, changed from this shape. Okay, now it is different from the previous one. So somehow we just reverse the whole structure, reverse the whole data. And if we small values, there may be possibilities. There may be possibilities for small values of this for your data, for your variable x, there may be chances of 1. And then for large values of this, you have chances of like 0. At the same time, once we are just generating a report data, in that data you consider if it is a disease, it is infected, then it considered is 0, and if it is non-infected, then we will consider 1. At the same time, one person can assume if it is infected, then we will consider 1, and if it is not infected, then we will consider 0. Then the structure will be look like this of the previous plot. Of our data plot, the structure will be just in this shape if a person assume 1 and 0 in different mode. He says infected person is 1 and non-infected person is 0. So accordingly, the parameters A and B will be associated with that data. There will be no such change in the shape. The only thing is that this parameter A and B will take values accordingly. That's the only change in your functional form. So I think there will be no such issue with this. Any doubt in this data?
It tells about the change in the platelet count. Increase or decrease is infected or non-infected, not the other way.
Okay, and the actually point is what we are saying in this. If I just the point is how you are assuming in that form. The point is how you are assuming. The point is here what we have assumed. See if one of you or one of us say if it is we'll say it is a count. So in that case, if one of us say in the initial phase the low count represent the infected, and for infected person we consider the response as a 1, and for non-infected person, which is shown here, we consider y or response variable as a 0. So it can be changed by person to person. We are considering actually the data is a person is infected and a person is not infected. Now it's all up to us what we are considering. We are considering a non-infected person is 1 and infected person is 0, or we are considering a non-infected person is 0 and infected person as a 1. So point is, as per their choices, as per their assumptions, the curve will be look like. So either this will be this, if we just assume in our real data setup, the data we are just generated, and if we are just considering this 3 is equal to say plus, in that case, this whole structure will be just reverse in this direction. Is it clear? Is it good?
Yes, fine.
Okay.
In case if the I'm just worried. In case if the infected non-infected is unequal.
Unequal in the sense?
According to the prevalence, let us assume only 20% is infected, and whether the sample the command will work.
Of course. The point. No. Yes.
X1 and X2,
Good.
They have to be unequal.
Good. I got your point. So there is no such conditions. Then the number of actually the thing is random. So how we do know that out of 40%, how many persons will be infected and how many persons will be not infected? So you can change the sample to 30, 10 or like that. But overall, the point is, if you say in the sample size or proportion point of view, the overall point is in a particular category, either is infected or non-infected, or either it is 1 or 0, you have sufficient number of observations. So there is no as such definition of sufficient numbers, but we are expecting say sufficient number of observations, say N1 observation for non-infected and N2 observation for infected. So both N1 and N2 will be a sufficient number of, means those will contribute in their estimation. At least we have so many observations in both categories. Say those will contribute in kind of we will say in the estimation of their coefficient. So that is the only percent.
No, I got that. I'm sorry, I got that. No, in terms of which command, see, it's only in the generation you need to differentiate the number N1 and N2, or is it possible in the sample where you can sample from one distribution for the positive and another distribution from the zeros, different size, and merge it? Is it that is the one I just asked.
So my only, I think, as I just get your point, the point is that either it in 0 or in 1. If I just say if in 1 there are more than 20 or 30 observation, in 0 there are 50, 60 observation, then it is sufficient enough. So there is not such condition, the equal number of or a equal number of kind of proportions will be there for the estimation purpose, right? Sufficient number of observation will be in each category. If that is exists, then in that case we will get good result. Okay.
Okay. Fine.
Or at the same time, if you just, I think I'm not trying to do this, but let me explain. The actual issue is, if you just go again back to our data, so here it is. So if you just plot, if you just ask this question, then let me explain. So actual point is, if observations are defined here, say below 60, and observations are defined here, say above 110, then categories are exactly separate out. But the point is, those observations, few observations in one side is near to 80, and few observations in 0 also near to 80. So actual point is, when you will define your model, when you fit your model, then the actual point will be these particular observations, platelet counts will be go with 1 or will go with 0. The whole thing, the whole estimation or whole efficiency of the model is actually belongs to that particular. Anyone with platelets 140, any model in somehow can assign a value 0 to that. Any value with around 150 or 140, any model can assign a value 1 to that. But if the point is near to 80, near to 100 or near to 90, that is the actual situation or actual possibility or efficiency will be measure of the model. Do you get my point? So number of observation is not as such, I think, critical in that case. The point is those observations are mixed up on their boundaries. So somehow in the previous plot, we are trying to find out, say few observations, those are here, that is good. Few observations are here, that is good. But those observation belongs to this line, then we will define some kind of probability. Here the point is, it is kind of observation, say in somehow these are the observation. So those value lies to between to this, those are in the positive side, those are greater than 0.5 on the y-axis. We are assigning the functional value more than 0.5. So we are expecting a value lies here that has the probability more than 0.5. Then we will assign to the 1 y is equal to one side response. And if it a value lies some over here, then it assign a value 0.32, then we are saying that it will be somehow lies in this case. Okay, so that is the actually challenge with the S function or the sigmoid function when we estimate the things. I think this will be clear. Now the point is, sometime time is little, we are quite late actually. I think it is 11:20 right now, or even we did not.
Yes, sir, it is 11:20. So, like, it's up to you whether you would like to have a break or you'd like to continue, or you can ask the participants also how they're feeling.
Let's take a 10 to 15 minute breaks here. 11:20 is there, and as I let's say I have some